Let's see. That's up and running. That's up and running. Where did I leave this off? Okay. I still can't turn these points on and off. I want to get this slider working again. I think I just disabled it, but I want to make it work again. This is for inspecting branches, right? I think I want to do something smarter than that someday, maybe today even, but might as well just make the branch segments clickable themselves, right? Okay, so let's see. Yeah, there's all sorts of stuff we could look at. I kind of want the ability to turn points on and off. Hello, Abner. Thanks for hosting the channel, the stream on your channel. It's much appreciated. So, like, there's some weird stuff, switching back to this other train I thought I was going with before. What is this branch even coming from? Is that because this isn't high enough? No, that's not the threshold. Here it is. There's the threshold. You gotta turn that on, because otherwise you get these weird branches that don't make any sense. Okay, so there's with the threshold. And now we can adjust things like the growth amount. Yeah, it's about width, thickness stuff. So there we get some kind of decent looking tree. Yeah, it's actually not the worst tree ever. And if I move this point over, I wish it would grow taller up, which is what this slider here is supposed to influence. So the other thing is, like, I think the distance to these points should be a factor, because when I put this farther away, I want it to, like, try to grow farther to get there faster. And right now it's just sort of showing a direction and not a distance, sort of. If that makes sense, and I don't think that's what I want it to do. So maybe there's something I should change, but I really think I should start by making it possible to add and remove points from this system. And I've also been saying that I want to get away from having everything be at the same angle all the time. But I don't know, I still like that shape right there is not quite right. That should jut out a little bit farther upwards, right? So I want to adjust these various things. Alright, let's start by making points addable and removable. That seems like what I am feeling most today. And so, just to clarify the rules of this game, here's what I'm doing. This what we're seeing right now is 4coder as it exists right now, not the stable version that I have set aside. That's the version I most recently released. This is the newer version with a bunch of bug fixes, a partial or a start to word complete. It also has, while I'm here, I'll just go ahead and show you that it completely has all of the features of command line now. So we can do something like I can go to test.basic.cpp right away by including it on the line. So there's my file. You can see I've also redone my my layout a little bit, and we'll see why. I want to see if it even works out, because there's one reason why it might be kind of janky to do this, and I want to see if it's too janky, what I need to do, because that's something I need to start thinking about. I have kind of a plan for what I want to do there. But yeah, the rest of the details on what all these, command line parameters are that are available right now will be available once I release this build. I'll let you know what all the command line options are. Okay. Let's see. I'm not quite situated correctly. There we go. Okay, so let's get to looking at this code. App color. Oops, not that one. Alright. So what I'd kind of like to be able to do, which I can't do quite yet, is just switch back and forth between these two with my comma, which is what I normally use for switching back and forth. And then have a separate button for switching down here if I ever wanted to, but I'd actually like never want to switch to this panel down here. So I have an idea for what I want to do with layouts, but I'm putting my compilation down here now so that I can keep two files open at the same time. And I just got to remember that when I'm going from left to right, it's 2 commas for now, because it kind of rotates around is what it does. Doesn't even rotate really, it just goes to the next based on some arbitrary order. Okay, so adding and removing points. To do that, I have to first make sure the number of points isn't hard-coded, because it very well could be hard-coded into the array. Inspecto branch, p moving, no, actually, is this in the other struct? Tree params, hotspots, aha, yes, the hotspots thing. So tree params has a like fixed number there, which is nice. And what I'd like to be able to do is just say right clicks will be for, if I right click a dot, it deletes the dot. If I right click a spot that doesn't do anything else, that adds a dot there, is my plan, right? So, where's my for loop? Right here I go over all of the do draggable stuff. And then what I want to do is I want to say, look, if at any point I do, like, right click, something like this, and I'll just go ahead and copy all those parameters for now because I'm not sure which ones I don't want. I think I might want all of them. Then here's where I'll put logic for deleting. Delete this point. Somehow, kinda tricky. Make sure to think about it a bit, dude. And then, down here, if the mouse isn't consumed yet, and it's a right click, add a point. Okay. Let's see, so now I need just this thing here, and as always, I always end up regretting my, like, first pass UIs, because I'm always like, well, this has just got to be a quick little hack, and it won't matter if it works or not, and then it always turns out that over time you need something better. And so what I should do is from now on, when I sit down to write a UI, I'll just start with, like, I'll take the full time it takes to just make something that will last forever, rather than trying to simplify, because I always end up wanting to do it right in the end. I learned it here, and I've learned it on 4coder. Well, now I've learned it for sure, I think. But, you know, probably not. We'll see. Okay. If mouse RP, I believe. I don't remember because this is a system I don't usually use. Mouse. Is there any mention of RP in here? PR of R equals. Okay, what about mouse dot stuff? PR. There it is. So if it's mouse, press right, and hit check mouse X, mouse Y rect. Alright. Then result equals 1. mouse consumed equals 1. And what the hell? Why am I not checking if mouse consumed in previous things? Did I, like, totally discard that? What was the whole... There's definitely a good reason for that, and... Oh, I guess the assumption here is none of these overlap, so who cares? But with these I care. Okay, because they might overlap with buttons. Actually, that sucks. If they overlap with buttons, then I want them to go first. Okay, so first of all, you guys, you come first. Secondly, if, let's see, if the mouse is not consumed, right? Okay. Then let's see. Now I have to do this. So the reason I said this is kind of tricky is that, well, there's two good reasons why it's kind of tricky. The first one is the basic thing that whenever you're deleting something out of an array, what are you going to do? Are you going to copy something from the end and put it in the middle, or do you need them to shift together? I don't see any reason why they should need to shift together, because I don't rely on their order in anything. At least I shouldn't be. I wanted it to be order independent, so let's see, probably swap to the middle. And what happens with the indexes? Well, the other problem with the indexes is if I put something in the spot where something else used to be, it's possible that it now thinks that's the one that's moving, and then it jumps there. So what I will do is I will say that if we detect this, then p moving equals, and down here I have some logic about p moving, don't I? I need to move that up. Alright, then p moving equals -1. Okay. Now do right click. It's not using the active variable at all, so we'll actually get rid of that. Do right click. Alright, so now to delete this point, we're just going to say, okay, vars params dot hotspots. Okay, that's enough. What's going on here? Why is there there's a hotspot array right there, or pointer. Let's get hotspots right there. Hotspot array actually would be a better name. Let's grab you, put you right there. Wait a minute. Hotspot. Yes. Yes. Yes, yes, yes. Okay, so and I do use I right there, and then that's it, because I use index after that. Okay, so what I should be doing, make this nice and easy, is no array pointer, hotspot starts there, I plus the hotspot every time I'm done, and then when I do this, what I want to do is, I do need a hotspots array, okay. Hotspot array. hotspot equals hotspot array. I was almost tempted to do the autocomplete just there. It doesn't work yet. Let me show you what would happen if I tried to do autocomplete. Oh, this is using custom, so it won't even matter. Okay. Yeah, custom doesn't have that bound. I have to use the I have to override custom and use default to test new things, which is kind of easy now that I have command line parameters, but anyway. So for I equals 0 plus plus I plus plus hotspot, get the index value. And then in here what's going to happen is we do the current hotspot equals, we go to the hotspot array and we get treegen hotspot count -1. Actually, let's just take hotspot count because we're also going to have to decrease that. Grab it off the back, put it here. If it happens to be putting it back on itself, it doesn't matter. And then we just subtract 1 from I. We subtract 1 from hotspot, and then it will repeat the same location with the new point there instead. And as we said, it doesn't, oh, that's just going to move all the points in here. Okay, so what I actually should do is just when that happens, okay, let's just say we break when that happens, because if I did what I was going to do there, it would just delete all of them. Yeah. Okay. Okay. Now, we should be able to delete these guys. Let's see if it works. Doop. 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 And without any hotspots, nothing works. Awesome. Okay, so they can be deleted. That's kind of cool. Now, I want to do if not mouse consumed. Mouse is not consumed yet. Then, and let's see, and mouse pressed right. Then, if params hotspot count is less than vars params or vars hotspot max, then hotspot array vars params dot hotspot count plus equals, and then I want like mouse vec, right? And that would be mouse vec as in the vec2 called mouse vec that you get when you do mouse vec dot x equals mouse x. Actually, I bet I can just use, this will be better. I'll just use v2 mouse x mouse y, because I forget I have that sometimes. Okay, hotspot max is not a member, see line 207. Hotspot max. Let's look for params dot hotspot count. This would be vars hotspot max equals 10. When I ask for how many do I want to allocate here, this should be, why did I put that over there? I want this to go right here. 411. Yeah, I like having the compilation down there. That's more like back when I used to use Visual Studio. And that's a little better for me. If I can just get this swapping screens down a little better. Let's see. Oh, okay. Not sure if I've defined those yet, but I'm kind of like sick of typing out the long version, so let me go define them right now. Type def, real 32, float f32. Type def, double f64. Type def, I8, B8. Type def, I32, B32. Alright, we don't need to convert to those completely right now, but I prefer them to exist. Alright. There's a new point. I can move it about. I can get up to 10 points on the screen at once. Okay. I assume that's 10, because I can't get any more on there. Let's see if I can divide them out into 5 on each side. Yep. Okay, so that's definitely 10. Let me put some, and you can see why I want it to be based on distance somewhat. That's some weird behavior that it's exhibiting. I'm not sure why it's not drawing the block at all. It's definitely drawing the yellow spot for all the points, so that's good. But sometimes it's deciding not to draw the yellow block. Okay, this is like a puzzle game. Look at this. So if I clicked on this one, I saw that only that one over there still had a block. When I click on this one, they all lose their block, right? It's like playing the witness and going, wait, what's the rule? So now there's some kind of explicit ordering, or there's some sort of total ordering is the word I'm looking for, between these points is my guess, right? So this is the second one. Here's the third one. Now here I have 4 points lighting up, 5 points lighting up. No. 6 points lighting up, etc., right? You can see what I'm talking about. 7 points lighting up, 8 points lighting up, 9 points lighting up, 10 points lighting up. And now I've learned the rule for this puzzle, except that unlike the witness where now I can go and solve a bunch of panels, instead what I have to do is make it stop happening. So that's kind of different. In the meantime, why can I, well, first of all, can I delete these? Alright, I can. Whoops. Delete you, delete you, delete, delete. Boop. Yeah, it makes really big ones. When it's closer, it should be smaller. Doop, doop. Let's see, thinner. Farther up. One over here. That's interesting. Without that one, it's like taller. Oh, because each one I add changes the average. Yeah, I don't think I like that formula a ton. Whatever I'm like, the things I'm doing leads to like, look at that. It makes just a bunch of stuff pointing straight towards this. Isn't really what I wanted it to do. So I'd say now let's take a little more time to think about how these points should actually be treated, what the algorithm should actually be. Because right now I'm just making branches longer. Let's say the branch length has nothing to do with it. I want to swap the total concept there and say branch length has nothing to do with it, and we'll go with a completely different idea. So let's go down here to weight. I introduced this idea of weight, but I'm going to say, let's say no weight. No weight. no weight, and in place of the concept of weight, I'll just have, oops, not 4th of 23. I don't even think, or not even 23. You can't, there's no 23-bit float. There might be, but I don't know about it. BP step, there it is. I'm going to just take the default step amount. See, the great thing about having compilation there is I can press Alt-M and it won't ruin the other one, and so my screen's just like stable now, and it's awesome. Alright, so... oh... 348. Need jump to error still. Sometimes I type 248 instead of 348. Oh, 348. Also, sometimes I hit the go-to key the wrong way. That seems to happen a lot. Towards new P. Initialized but never used. Alright, so this thing is now just totally ignoring these points entirely. They're irrelevant again, so bye-bye all the points. They don't matter. What kind of shapes do I have under this configuration right now? I wonder. This is like the way it used to work. Yes, it's back to perfect, near perfect symmetry, which is annoying. But we're going to now try to break the symmetry by breaking rotations instead of by breaking lengths. I think that might lead to better effects. Yes. Okay, enough playing with this. So that idea there might have been not a great idea, but let's do something completely different. Instead, what I'd like to do is say, what if, so let's do this idea. So the idea is still to get, we'll just call this weighted theta now. So we have some kind of theta, which was the original theta amount, and now we're going to have like a weighted version of theta where we're going to find a new theta value. What I'll do is I'll call this like default step, and pull it out too. Default step. Okay. Now, what we'll do is we'll say in this branch here, if I go back to it, the weighted theta is just theta for now. And here the weighted theta is just theta, but in here we're going to actually compute something interesting here. And now it's math time. So let me pull up some math, some geometry enabled equipment. There we go. This is my geometry enabled application. It can do lines and shapes. So the idea here is I have some starting point, and I have some hotspot out here, and I have some default angle that and length that leads to me wanting to put down a point right here. And before I was saying, let's take a look at, the vector in this direction, project this here, and then use that to determine the length of this, so we get things that are longer that move towards that. But that's just been, as we've seen, kind of disastrous in my opinion. Maybe you thought it was getting good, I did not. But maybe the idea should be more like there's a range, not of distances that will apply in this direction, but a range of angles that we're willing to sweep. So maybe it'll come out this far here and this far here, and they're all the same length. They're supposed to make sort of a perfect little arc here. Clearly they don't. It's a terrible arc, Alan. Back it up. Back that up. There we go. Okay. Nice little circle sector thing. And the idea is which angle in this set of angles gets us closest to that point, that hotspot there. And really it's not that hotspot, it's which one maximizes the distance to all these hotspots, but as I've seen, that's kind of been like kind of weird, because what if I put a hotspot over here? That's gonna like influence it in weird ways. So what I'll probably do is say what's the nearest hotspot to this spot here? And then use that and say, look, is it within I want to like some rules basically, right? So say these are my hotspots. What's the nearest hotspot to this point here? Oh, it's right here, right? It actually might be this one the way I've drawn it, right? So maybe we'll say actually it's this one. I don't know. Maybe what we'll do is we'll say find me all the hotspots that if it's going to shoot out this direction, draw the perpendicular line here, so that everything on this side, that seems right. All the hotspots on this side of the line apply, all the hotspots on this side of the line do not apply. So if I use colors here, this is the bad side. No. There we go. This is the good side. That's shading. I'm being artistic and shading one side with a red color and shading the other side with a green color. Now, if I do that, I look at the set of all points on this side of the line, and right now I'm taking the easy case where it's one point. I want to pick the angle in this sector here, this range of angles that's going to maximize or minimize the distance to all of the points, right? And that are in that region. And the idea is if there's no hotspots over here at all, don't put a line down. If there's a hotspot, put the line down at its normal length and then rotate it appropriately within this range. So now I need to figure out, this is kind of an interesting geometry problem, what is the optimal angle within that angle range for the branch? Okay, so I mean, what's the formula for the distance from A to B, where B is some point on a circle who's got a known center and a radius and some theta? This is the information that I need, right? So basically these things are the formula for B, and A has some xy point. I need to find a formula for the distance between these 2 points. So that's the geo problem of the day, right? Distance from a point to a point on a circle. So let's see. The point on the circle B is basically just going to be the center point plus what? Plus the radius times you know, the sort of, it's not actually like this. It's like, I don't remember what name I have for this in my code, but in complex, now that I've been, you know, practicing my complex algebra, and shit, Krita's doing a thing where it's like insisting on selecting a color and never drawing for some reason. Like, this is a useful mode. 1 minute. Erase shit, and then I can draw shit again. But now I need like black shit. Okay, there we go. So in complex variables, you would just write sec here of theta. Although that's not really the right thing, 'cause I'm using vectors, not complex variables. So what is the thing I need? It's in my math thing, so I'll have to switch to math. vector related stuff. This is definitely a vector 2 type thing. Polar to Cartesian. Oh god, Alan, that's a terrible name. Look at how long that is. I'm just gonna cheat. Since I have a really short name that I like think of now, I'm gonna just give myself that name. And then I can multiply the result. Like I said in the past, I'm not trying to be efficient right now, so equals cos theta degrees. And honestly, this is no less efficient than that other one, just because I wrapped that all into one function. I didn't actually do anything to make it efficient compared to this, so what difference am I even talking about? None. That's what. So, yes. Now, going back to, well, let me check. Yeah, there we go. Okay, so now going back to the math. R equals, or S plus R sec of theta, right? Where sec of theta is basically you input an angle and it gives you the unit vector in that angle. Okay. So that gives me B, and then I can plug that and A into a distance formula. So what exactly is x in this? So B of x is C of x plus R cosine. So C cos. I'll just write cos and drop the theta. And B of y equals C of y plus R sine. Okay. And obviously we have A of x and B of x, so, or A of x and A of y, so then the distance, D, is equal to, distance is equal to A of x minus C of x minus R cosine theta so that's A minus B squared plus, this will just be, I'll just do square distances, because whenever, as Shawn said, if you just do least squares, you get better results in pretty much everything anyway. I don't know if he actually said that, but he suggested that I do least squares, and that's because, you know, everyone does least squares, because, you know, for some reason it's cool. And it's also easier to compute squares in this case, so why not, right? Not bx, why do I keep wanting to do that? Ay minus cy minus r sine. So it looks like we're going to go with least square distance to all the points. Kind of cool. Let's see, I got a link. I might have completely misinterpreted what this actually means. Oh, you're talking about statistics? Like the least, is this one of the, is this, I remember this from statistics now. Squares of the errors made in the results of every single equation. I see. No, I was thinking, yeah, so least squares is not what I was thinking. Least squares is like, I'll just put it up here, is like this, sort of that. I learned that in statistics, but I promptly forgot about it because I didn't really like statistics for some reason. I thought you were talking about, like, I know that when I was researching text layout algorithms, the one that ended up being the really good one that they used in like the original tech and stuff to minimize the jaggedness of the ends of lines was to minimize. Basically, the algorithm was take the number of spaces at the end of each line and square the number of spaces, square that for each line, and then minimize the sum of that. So I was thinking like min sum squares type optimization problem, which is what I'm going with here. Okay. It's kind of dark. It feels kind of dark to me. I'm going to turn this on. Okay. Distance to a subspace. All right. So, I'll take this. This is d squared between. And now what I need to know, d squareds are simple, so I'm just going to call it d, even though we know it's the squared distance. D equals distance squared, right? And I need to know how to optimize, to minimize this number for a specific value of theta. Like, I need to know the value of theta for which this is the least, is what I want. And not just that, I need to know that for the within a range of 2 thetas, right? So that's a pretty interesting problem. The first thing I need to do is probably going to be to try to take the derivative of this with respect to theta. So let's do some calc. The first term here, the derivative of that and that will be 0 with respect to theta. The derivative of this will be negative cosine, so arc sine theta, or, right, times, well, times 2 times ax minus cx minus r cos. Right? Stop me if I'm wrong, because I've got a little bit of a rusty spot in my calc part of my brain, because I haven't taken calc in years since I finished IFEQ. I don't actually know this very well, but that seems right? You take negative cosine becomes sine, and that's the derivative of the inside, and then the derivative of the outside is 2 times all that. And then negative sine, so this is actually minus d prime, by the way, is minus, take r cos a of, oh, gotta do the 2 first, 2, nice big parenthesis for that, even bigger in here. Now, keep it readable so I can manage this without getting distracted. 2 ay minus cy minus r sine. Okay, so that should be the derivative of d squared with respect to theta, and I want the min value of that. Like, that might not be the right way since it's not a polynomial. I mean, if I ask for the zeros of this, right, if I ask for where is this 0, that's going to give me an infinite number of points. I can limit it to the number of points in the range from negative pi to pi. Yeah, so let's set that to 0 and find our mins and maxes. Actually, what would you do with this? I mean, I can easily find the min for, say, 1 point. But the question is, if I have this and another thing and I want the min of the two of them, right? I mean, if I just had 1 point, the min is always the thing that rotates closest to the angle towards that point. If I have another point that's farther away over here, then what you would want it to do is favor this one because it's closer by some amount. But would I do that by taking the several points and adding them up this way somehow? Is that really what I would want to do? Because I mean, what I could do is say that the d squared, like the d squared sum, right, the sum of all of those, is just going to be a sum of a bunch of equations like this, right? The only difference will be then each equation, ax and ay changes, right? That will be the same everywhere. That will be the same everywhere. So really, it becomes kind of weird, right? If I've even done this correctly. Again, I don't know that I have. If that's the only thing changing everywhere, then the sum of the whole thing how does that make sense? Why would it be? Because do you see what I'm thinking right now? If I added all those up, like if I had the sum of a bunch of these and I took the derivative of all of them, I would get a bunch of terms like this, right? And then you could say, okay, all the r sine 2's come together and all the minus r cosine 2's come together. They all add up. If that's going to be the case, they're all going to be, oh, I see why. So each time I add in some amount of x and then I subtract that amount back out from c so that, right, and then minus r cosine at each one means what? It means, I don't know. Math is weird. It's possibly a little more or a little less, really, is what it means of whatever C contributed. But the same amount for all of them. Okay, so I'm like solving two problems at once here. Let me bracket that and come down here and say, what if I just have 2 points A and B? This is going to be a math episode, it looks like, and I'll actually get to figuring this whole thing out more properly next time. So I have 2 points A and B, but as you know, I like math, so I don't mind taking a break to learn something. The distance between those 2 points, the distance squared between those 2 points, is d equals ax minus bx squared plus ay minus by squared, right? By squared. And if I have a bunch of these, this is distance, we'll call this distance to B. So A is my central point, B is my first one, C, D, dot, 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 right? So this is distance to B. There's also a distance to C, a distance to D, etc., right? So the sum of all of my distances would, just be like this over and over again. And then the derivatives of all of these looks like this, right? Distance to B derivative equals, and if this is all with respect to some, if bx and by are both functions of, for example, theta, then it becomes the derivative, or 2 times the derivative of negative bx times ax minus bx plus 2 times the derivative of by minus oh, that's backwards, because b is not, okay, so back that up, back that up, back that up. Okay, so if I'm putting it on that side, the derivative of ax with respect to whichever variable times ax minus bx. Derivative of the inside times the outside. Derivative of the outside with respect to the inside times the derivative of the inside, right? So that's 2, the square comes down. Yes, this is good. And then, again, 2a prime y times ay minus by. Okay, great. So that's the derivative with respect to whichever variable, like theta, of the distance from a to b as you move that variable around. That changes ax and ay. Let's see. And when I take the sum of all of those, the sum of a bunch of derivatives is just the sum of the derivatives, right? The derivative of a sum is the sum of the derivatives, right? So really the derivative of the whole thing, if I call this like s, then s prime is just the sum of all of those, right? It's just d b prime plus dc prime dot dot dot. Okay. Now, the point is, once I've got a formula like that, what good does it do me? Because first of all, I know that these are all going to have this form, right? Every single one of them is going to say this. The only thing that changes from one to one is the ax minus bx. So really, what this is going to equal is 2ax prime times, and I'm doing big parents now without stopping myself because this is the sum of all of these things, ax minus bx plus ax minus cx plus etc., etc., etc. Okay, so that becomes like the sum of ax minus, I'm going to call it xx because I'm just, abusing notation forever. So there we go, across, all of the letters, so I'll call it across the ABCs, right? Well, actually, this is the BCDs because we don't start at A. Across the BCDs. Although if we started at A, it would curiously make no difference because you would just be putting zeros in here, right? Okay, so that's with x going across all those. And then plus 2 times, and this is the part that I find really interesting, is that the derivative, the variable isn't actually spread out everywhere in this thing. The variable is actually, well, I mean the derivative is sectioned off, but ax and ay are still varied on theta. So we'll see. BCD dot 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 of ay x y. There. Okay. Right. Now, so really, what this equals is 2 times, let me just bracket the 2 out completely, ax prime times times, let's see, some number, which is the number of things there, I'll call that n, right? So times n times ax minus the sum, you know, of the x's. Plus ay prime, and there it is. That's what I was looking for. I've completely now pulled out the variable into a fixed number of spots. There's only a fixed number of points in this equation now where a variable actually shows up. X, y. And that's significant, and I can explain to you why now. Whoops. Because if we only have a fixed number of points in this equation where the variable can show up, namely here, 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 and here, then that makes this is actually a constant that I calculate that by running the loop. That's a constant in this formula. This is a constant. Every time I run the problem, I get new constants, but those three things are just constants, and so really all I have to solve is, once I've plugged in my sines and cosines the right way, I have to solve this equation once for, you know, those positions of the variables, and then once I have that solution, I hopefully have something where I just plug constants in. So the exact thing that we're solving here, and if I distribute that too, I would just get a new constant there, a new constant there. Yeah, so the 2 we can ignore. Really, the formula, the generic version of this formula is going to be ax prime and ax minus, let's call this minus p plus a y prime and a y minus q. Right? So for some constants n, p, and q, we'll get this thing. Now this right here, we want to know when this equals 0. And now we can plug in, because we know ax and ay. We set these earlier. Ax, now I can go back to solving the version where those are, where the point is moving around an arc. Ax, ay, and this equals some constant x plus r cos theta, and this is some constant y. And again, just remember that theta is our variable here. Everything else is constant. So r is constant. These x's and y's are constant. And I said that it was cosine, but it is not. It is sine. Okay. Yes, okay. Sick. I called it sick? Wait a minute. You fool. It's called kiss. Jeez. Okay. It's weird how things just occur to me at random times. Okay. Anyway, the trick now is, what if I want a derivative of these guys, and what I get is that ax prime equals negative r sine, and ay prime equals r cosine. Right? Okay. So coming over here, we get negative r sine theta times n r cosine theta minus p plus, and let's see, r cosine theta. Again, I'm dropping all the thetas, but these are all just with respect to theta. Actually, I didn't drop that theta there. It's not, bloop. Problem solved. N R sine, I put my negative there, right? Yeah, sine minus Q. Bloop. Okay. and this is equal to 0, hopefully. For which thetas is this solution solved? Now that's a problem that I'm almost certainly not going to be able to solve. Jeez. Well, we can always try. So we know that what this really means, if you see here there's a minus sign, so that's nice, because that means I can just say that what's really going on here is that these two sides, these two terms here are equal, right? There's an r on both sides, so that's irrelevant. Let's erase that. Okay, so this gets kind of cool, right? On both sides, there's an nr cosine sine. nr sine cosine, right? Am I crazy? That means that if I eliminate that on both sides, I get minus p sine theta equals minus, this seems too good to be true, cosine theta. Have I made a mistake? That's like too much, right? Because I've eliminated the radius now. There must be a mistake, because if the radius isn't involved, anything like that doesn't make sense. nr sine cosine equals nr. Is that real though? I mean, it could be that the radius is actually irrelevant in determining the angle, right? Maybe it could be true. I don't know. I mean, if you think about it, it might be true, because say you have a small circle here, and you have some point out here. This line straight towards that point, yeah, as that circle grows, that's always the closest point. No matter what radius I have, that's always the closest point. Even if this circle goes way out here, that's still the closest point. Yeah, I think that actually radius is irrelevant, maybe. Shawn's asking what exactly I'm trying to do, and it might be that I've overcomplicated it. But the point is that there might be more than one point, right? Here's a center point here. Here's a circle. If I pick a point out here, obviously, yes, this angle here is always the closest point. The point is, I wanted to have more than that. Like, here's a point, here's a point, here's a point, and I'm limited to like this arc or this sector of the circle here. I want to pick a point in this part of the circle that minimizes the distance to all of these things. But I decided not to do minimize distance. I decided to do minimize distance squared. And it looks like the minimal distance squared is irrelevant. Like, the radius is irrelevant here, too, it seems. Which is surprising to me. I wouldn't have expected that. I mean, maybe I'm being a moron and it's obvious. There might be a really obvious reason why this should be true. But yeah. Shawn, if you want to tell me how you would do it, I'd love to hear. Can I voice chat? Can you use Skype? Alright, let's get on Skype. Oh my goodness. I mean, Skype is a gigantic piece of pile of poo-poo, but I still find it more convenient than like Google Hangouts. You're gonna need my name. Oh, are they gonna improve your Skype experience? Well, yeah. That'll happen once in a while. I gotta say though, every time they improved my Skype experience, I got brand new ads that I hadn't seen, and more of them fit on the screen after each one. Okay, let me send you my name. I don't really know how to whisper, but I don't know. I don't know how much I care. So here it is. Let me actually double check that that's right. Alright, Alan Webster with a little minus in between like this. I'll probably excerpt that from the YouTube video, but other than that. Yeah, as long as I do something to make sure that it's a finite number of unwanted requests, I don't really care. Alright, here we go. I'm ready to go, so you can just go ahead and call me when you're set, Shawn. There we go. Let's see. Hi. Alright. We should be good.
All right, so hold on. I wanna make sure that I understand your problem because I just opened some code that I have and it should solve your problem.
Okay.
So what you have is you have n number of points, and you essentially have a circle arc, which could be defined by 3 points.
Okay. Yes.
And you want to find the thing that minimizes the distance within that.
I want to find the thing. Well, I think what I'd love to have is somewhere within the arc of the 3 points. So I was just going to go with it's always the same radius and at some point on like the arc. But if you have more complicated than that, that's even better. But I just want a thing that you have this sort of field of points, and you want the point in the sort of part of the arc of the circle that minimizes the distance, so the sum of the distance to all the points, right?
The sum of the distance to all the points. What does that mean?
So you said, like you said, you have some n number of points that you want to minimize a distance to.
Okay.
Right. So that's what I mean by the sum distance, right? The sum of the distance to all of those different points, and you're picking up a new point that is going to minimize those distances.
You're picking a new point that's going.
Yeah, the new point is one on the sector or one on the arc of the circle.
Oh, I see. And it has to be within the arc.
Yeah.
Hold on. Okay, I wasn't understanding your question. Hold on, let me think about it for 2 seconds.
Sure, I'll let you do that while I put my little picture up here. There we go.
the points are like behind the arc. Do you know what I mean? Like if there's a center line to the arc and they sit 180 degrees from it, or
Uh,
something larger than 90 degrees away from it, I guess.
right. Okay, I think I missed about 5 to 10 seconds of what you were explaining because I heard you say the center of the arc or something like this, and then what came
Okay, so
before
what do
that?
you do in the case, like, I can see where this is, like, logical if
Hmm.
they're somewhat within the range of the
Yeah.
arc, but what do you do when they're, like, behind the
Right.
arc?
So the first thing I'm doing is I'm saying there's some center, right? There's some vector that comes out of the point that's like the default location, and the arc is just some delta like above and below that angle, right? And does that make sense?
Yes.
And then the perpendicular to that center vector, right? I'm not considering anything behind that perpendicular, just everything like on the right
Oh,
hand
okay, so
side,
they're all
right?
within... Okay,
Yeah.
that
They're
makes...
all within 90 degrees of the center thing, basically. Yes, like you were saying.
Okay, so that makes a lot more sense.
Hmm.
So you need to find a point... So you need to find a point on the circle, or
Yes.
in the arc,
Yeah,
that is the closest to all of them.
yes, that minimizes the
Ugh.
distance to them. Yeah. I mean,
Oh.
the easy thing to do, and this is one thing I thought about doing, was just say find a near point and like maybe take the nearest 2 points and average the distance to them, and then at a certain point ignore. I like to get more like, yeah, that would be like a fine heuristic. I just wanted to see how hard it would be to find such a formula in general before I did a heuristic on it.
Yeah, no, that's not what I thought you were doing. I thought you were doing
And
something
then,
different.
yeah, the other thing is I could do actual distances. I just left it at distance squared so that I didn't have to calculate each distance with a square root. Um, like I didn't know if that would. I mean, maybe the equation wouldn't be have a square root in the end. I haven't done it out to find out, but I suspect it would.
Yeah, I'm not sure if you generate... No, you couldn't do that. I ain't got no idea.
Hmm.
Sorry, I thought your problem was different. I thought you had a different problem.
What did you think I was doing? I'm just
I
curious
thought
based on
you
my
were
explanation.
trying to... I thought the solution that I thought you had
Mhm.
was to project each of those points
Mhm.
onto the arc in the
Okay.
closest point to all of them, and then you could average those.
Oh, I see. So you're saying like look at everything that's within this arc, right? Like
No, no, no. Just
or
take
not.
each point and
Yeah, yeah.
project them onto the arc.
Yeah, that's okay. Right, right. And then you look at the points as they were projected on the arc and average them into a single spot. Is what you're saying.
And then you can average those weighted with
Weighted with
how
how far
far
away
away.
they are. Yeah, that would be a good, easy way to get the effect that I want.
That's what I was thinking the solution is,
Mhm.
but the question that you have is a lot more complicated than that.
Yeah, I mean, that's the solution to like the actual problem. I'm sort of chasing down a rat hole of like a more, you know, fancy thing that's probably not going to pan out, and then I'll do that. But first, I want to see if I could make it work
Yeah,
doing this other thing.
that's the solution that I just said is very, very easy,
Yes.
but I don't know if it's correct.
Yeah, I mean, there's no correct or not. It might even have a better effect in the end. So I'll put that on the list of things I want to try if this doesn't pan out for any possible reason that might come up.
You know, if you need to know how to do that, like
Yeah.
finding
So
the
the
distance to an arc, I can tell you how to do that.
yeah, if you can tell me how to project on arc, that I mean, yeah, that would be interesting.
Okay, so do you want me to
Yeah.
tell you how
Yeah.
Okay, so you
Let's
have
talk
three
about it.
points, right? So you
Mhm.
have a center point on the arc, point 0 on
Okay.
the arc, and point 1 on the arc, right?
All right.
And then you have some point that's elsewhere.
Yes.
Okay, so the first thing you do is you create basically you tunnel through the arc, you create a vector
Mhm.
p1 minus p0.
We're talking from the radius of the arc,
Yeah,
or
from
from
the
the
radius,
center.
just radius 1 or whatever
Right.
you want.
Right. Okay.
So you create a vector between the 2 points,
Mhm.
and then you get you compute the length
Okay.
from from your query point. So if you want to label them so that I can see them.
Okay. So let's see. There's like this, if I'm understanding correctly, query point where we're starting. Here's like the destination point or something.
No, query point would be the destination point.
Oh,
So
oh, oh, oh!
call
I
out
see what
whatever
you
you
mean.
want.
Gotcha. Okay, I'll do it with that way. All right. Query there. This is some sort of center point then that we're starting
Sure,
from.
origin, whatever.
Right. Okay.
And then, so you have D, and then your other 2 points are P0 and P1 or whatever.
So wait, how many points should there be? I have 5 points right now. Is
You
that
should have 4 points.
okay? So I added a point incorrectly. So I have a query point that I'm curious about. Then I have the three oh the center point in the middle of the arc is what you're
Yeah,
talking
it's
about.
just the middle of the arc.
Okay, gotcha. Okay. Sure. I'll just give these terrible names and then we can keep going. Okay, great.
I call them PC for center point, P0 and P1 for the ones on the arc, and QP for the query point. You call them whatever you want.
All right, I'll go with P0 and P1 on the outer ones because that makes a lot of sense.
Okay, that C point is non-existent.
Mm-hmm.
Like your C,
Yeah,
you have on
yeah.
your
I
arc
think
there, that's not a thing.
there's no C. Oh, so when you say 3 points, are you talking about 3 points on an arc or the center of a circle and then 2 points on the arc?
Correct. Center of the circle with 2
Okay,
points on the arc.
that makes a lot more sense. Now I see why that works. Okay. Well, I see
All right.
why that might work. Okay, okay. P0, P1. Okay, I'm with you.
All right, I'll let you finish drawing this. I'm watching you draw it on stream, so there's somewhat of a delay. So I'm gonna wait till you have it drawn. All right, now we're getting somewhere. Q, and then you have P0 and P1. Okay, so first thing you do is you take you can take the squared length or length, it doesn't matter, from Q to P0 and from Q to P1.
Okay.
Call them whatever you want.
All right. So how about length 0 and length 1 with L's? That look really dumb. There we go. Okay.
All right, so then you find the point that would be on the surface of that circle, which is just your center point
Mm-hmm.
minus like the vector from the query point to the center. So just center point minus like the normalized vector.
Oh, so we're turning Q, P0, P1 into another arc? Is that what you're saying? Like we're well, if we take okay, you go ahead. I might have interrupted you too soon. Go ahead.
Okay, so you just all you want to do is you find where Q would lie on the surface. So basically, you just take that vector
Mm-hmm.
from Q to or from C to Q,
Mm-hmm.
and then you just normalize it.
Oh, okay, you normalize it. Right.
Yes,
Yes.
all you're doing is trying to find, and if you have a radius, multiply it by the radius. But we're assuming radius 1.
Right.
So you're just finding where
Great.
it would lie on the surface, on the
Okay.
circle rather.
So like, I don't know what you'd call that. Q.
Circle point? I don't know. That thing.
Yes. Okay. So we'll go with Q0 because it's normalized. Okay.
Then you. Why do you do that? Oh. It's length 0 and length 1. Now you got to get length 2.
That's the length to this point, I assume, right?
Yeah, so that length is your query point minus. So Q minus Q0,
Sure.
the length of that.
Okay, great.
So that's length 2, I guess.
Mm-hmm.
Okay, so now you got to choose which of the lengths you want, right?
Mm-hmm.
So if you take the dot product of the perpendicular vector
Mm-hmm.
between, okay, so make a new vector between P0 and P1. Call that
P0.
V or whatever you want.
Right. Okay. And that's okay. I've kind of drawn that to look perpendicular to this, but that's not necessarily true, right?
Right. That's just you. Just
Okay.
have,
Right.
So,
Okay.
So P0 minus P1.
Mm-hmm.
So that's a vector.
Right.
So then you get the perpendicular vector. It's 2D. It's very easy to do.
Mm-hmm. Yep. Okay. So there's something kind of close that goes like that. I'm not sure which way you'd want it to point, so I'll do it both ways.
It doesn't matter which way it points, but it matters for this next calculation because you're going to have to use the same reference point. So right now you have yeah, it doesn't matter.
Mm-hmm.
So basically you've just taken P1 minus P0. Right?
Yes.
So you've taken P1 minus P0. That's that vector.
Mm-hmm.
So you dot the perpendicular P1 minus P0.
Right. This thing here.
Yes. So P1 minus P0, perpendicular of that, dot it with your Q minus P0 vector.
Okay, so basically I have these two guys here. I take the perpendicular of the P1, P0, and I dot that with Q0, P0. Or is it dot it with Q, P0? Is it the projected version of the Q point
No, the
or the
original one.
original?
The
Okay.
original one.
Okay.
No, I'm sorry. Sorry. No. Q0, P0.
Okay. Okay. Got it. Yes. Got it. Dot those two things.
Yes.
I'll write that down.
I'll send you the code so that
Sure.
but you can draw it out so that you understand it.
Yes, that's what I have to do for me. Okay, great.
Okay, so if that dot product is greater than 0,
Mm-hmm.
then you know that the point is contained within the arc.
Ah, okay.
So Q0, no, it's Q, yeah, V, what?
V is just what I'm naming that
Okay,
perpendicular.
it's
Don't
not
worry about it.
Q0, it's Q0 minus P0.
Oh, shit. Yeah, okay. Alright, I need a name for that too. That's a pain
Call
in
it
the
U.
ass. Yes,
That's what I
U.
do.
Perfect. So U here, V here. Didn't even bother to undo that, so we'll erase it. Alright, U dot V is greater than 0. Then that's in the circle, right?
Yes, I think your arrows are backwards, but don't worry about it. You should be
Yeah.
using P1, not P0, because it's the origin basically is what you're trying to do.
Yeah, I wasn't sure. I just guessed.
Yeah.
I'm not super great at these. Okay, great.
Okay, so that means that it's greater than that. So if your dot product is greater than 0, that means you're within the circle. You're within the circle arc.
Okay.
So then your closest length is L2.
Ah, okay, I see. Okay, so then L2 is the distance. Sure.
L2 is the distance.
Awesome.
If that's not the case, then your closest distance is the smaller between L0 and L1.
Really? Let me
Because
think about that.
you're gonna be outside of the arc, so therefore your closest distance is however close you are to P0 or P1, whichever you're closest to is the closest point on the arc.
Oh, because those are endpoints of an arc. Right. Yes, yes. It's not a full circle. Perfect.
Right.
Makes sense. Okay. So otherwise it's min L0, L1. Awesome.
Yes.
Awesome.
So then once you know that, you know how close like all your points
Then you can
are.
get your distance to the point pretty quickly. Okay, cool.
Right, and then if you just use radius 1, you don't have to multiply anything, and then you can use squared. I don't know. I guess you could use squared. You don't need to take the square root, I guess, because you're just because then you just
Yeah,
use
you never
weights.
none of the numbers. Yeah, none of the numbers here like multiplied by L's or anything, so that wouldn't matter.
Right. So now that you have the closest, you have where it lies on the arc. You can just multiply that by its distance or square distance from the center point,
Yeah.
and then you have how far it is, like weighted.
So it's some sort
distance
of
away
weighted
from
distance, and then you apply the average. Use that to sort of weight average all the points on the arc and pick a new point. Okay.
Yes.
Awesome. That's a good idea.
That's what I would do.
That is pretty cool.
But I'm really lazy.
Yeah. I feel like I'm either really close to figuring out the thing I was doing or I was completely wrong, and so I'll try to finish it, and if it doesn't work out, then I'll put this aside and do this next time. Because this seems like much easier.
Yeah.
Okay.
It's
Awesome.
Easy to do.
Thank you. Awesome.
No problem.
Okay. Alright, let's see. So, if I don't get this to work, I can do that. I'll have to keep this mischief file open so that I can review that tomorrow morning and make sure I still have it. But, if I was right, then there should be a solution to this, but is there for sure, though? Yes, because these range from p to negative p and q to negative q. So it's kind of like you can take a sine and a cosine and multiply them by any amount of constant. They should be solvable no matter what, which is kind of cool. Right? I mean, if you're multiplying them by ones, they obviously have collision points, but I guess they would always have collision points no matter where you, like how much you multiplied them by. So now I just don't actually know how to solve that. If I knew how to solve the zeros of, like, if I knew how to solve this, right, I could find my mins and maxes, and then I would still need to, figure out which ones are mins, which ones are maxes, and pick one, and then try to pick the thing closest to the inside of the arc. But I don't really know what I'm missing today. Well, okay, here's what I could do. Yeah, sine over cosine is tangent, right? So how about the tangent of theta should equal q over p, right? That should be solvable. Q over P can be anything because tangent, yeah, it can give you anything between 0 and infinity. Or negative infinity and infinity, actually, right? Yeah, so that should be totally solvable as mins and maxes. I'm going to say that here's plan 1, and up there's plan 2, and next time I will try these and see which one I like. Let me save this. Tree math. Save. Okay. Let me shut down Skype. Alright. Alright, so I'm going to take a little bit of time now to swap over. We've done some math today. Shawn helped me learn some new math stuff, which was awesome. Now I'm going to do a little bit of 4coder stuff. Whoops, not run. 4coder. Okay. I have to run this one because this one you can see it opens in the Y directory or the Y drive instead of the W one, and that way it's the point being that it's separated off so that I can do compiles from here. Although what I should do, since I decided I like this better, is to do this first so that I can put my compiles down here. Okay. Let's actually pull up to do. Alright, so I need to work on word complete. That's what I promised today. Autocomplete for the word style of autocompletion. And what we can do is say I'm still thinking about that math thing. I've just thought of a case where yes, I see why it had to be limited to like a certain angle now. Okay. Yes, that makes sense. Alright, anyway, so let me show you how this actually works. So if I come over here and I do, well, no. If I'm going to demonstrate it, I need to demonstrate it from this one. So, first of all, I do this. Because what that right there says is, use a different DLL, and the capital D means strictly, only use this. If you can't find it, don't use the default, just don't use a DLL at all. Use this or nothing. Little d means non-strictly, so you can switch to the other one. So now when it runs, there's no DLL combined with it, and I just get the default behavior that's hard-coded in, which is the only behavior that I have for in development commands. It's the only way to get to that behavior. And I can show you what I've got so far. So here I am. Let me not actually pull open that. Let me go to this. Okay. So what I can do is I can put my cursor here, for example, and you see when you're doing autocomplete and say Emacs, the way word complete normally works is you type some stuff like part, and then you want to do autocomplete. So boom, you hit it and it's supposed to complete the word. So the first thing I needed was the ability to just pull out of the buffer this, like the alphanumeric chunk before me, and then I wanted to test that I could insert text. So that's the first thing I've done, is it just reads the alphanumeric part before you and inserts that. Now, what I need to do today will be listed in the to-do, so I've explained where we are, and right, so the thing I'm at now is for ed.cvp word complete. Okay, so yes, don't need to do either of those right now. I want to start having this search through the file and find the first match and then just autocomplete to that, right? And that won't be the correct solution either, because then you can only match to whichever word happens to be the first one it finds when it does the search. But that'll get us a step closer, and then I can make it incremental after that. So once I get here, yes, okay, here's where I need to do the search part. So I should have some stuff that does searching already. Well, let me switch to this one and look at do search. Okay. Um, Shawn, I do have a question actually. Now that I think about it, wouldn't the set of mins also need to include L2? I mean, I could pretty trivially think of a picture where you need to where the point is very close to the arc, and so it's closer to the point it projects to than to the endpoints. Yeah, I have to. Actually, why wouldn't it always be the point it projects to? Why wouldn't it always be L2? Huh. Yeah, I'll think about this when I'm off stream, but I don't think I totally get it. Yet. Okay. But it probably I don't doubt you. I just don't think I totally get it yet. Let's see. All right, so starting from here, I need to do something kind of like search. Well, that's just using a widget. That's not very helpful. Let me go to 4ed file view and see what that actually does. So search. All right. Do text field. Do text field. No, I'm looking for search still. It's funny. I'm using search. This code I'm reading is the code that I compiled that's powering my ability to search through it right now. Like, I'm using the search command and I'm reading the code that makes the search command work. It's kind of weird. It's a weird feeling when I think about it. Okay. So do I have a function here? Temp push array, r find string, buffer find string. Okay, so it's in buffer. I'm gonna just read it out of there because I think I'll get it better if I read it out of its where it's buffer find string. Okay, so I give it a buffer, start position, string, length, Spare, so it needs some spare stuff for what? What is it using spare for? Is match. Why does it need spare? String length. What is spare even doing, actually? Oh, I have to stringify that part of the buffer. Gotcha. Okay. So, this will really just be like buffer find string, buffer. Let's make the start position 0. Well, let's put the start position right after the cursor for now, just to be even more lazy. Because if it looks like my find string doesn't let me set beginnings and endings. So what I really need to do is say like, find string variants with explicit end position. Okay. Well, actually, yeah, it's more like that. Why should I have two operations when it's really just one? Right. So buffer find string, buffer word, and the string that I'm looking for. Why is there a 1 there? The string that I'm looking for is stir. It has a length of size, and now this thing needs some spare space. Actually, this all needs to go in here. If size is greater than 0, begin temp memory. That's where, okay, so that's where I've actually got the string stringified. So here's where the logic needs to go. Find the string size, and we need more spare space, so I'll put spare here. Spare. Spare needs to be at least large enough to hold ooh, this is kind of a nasty system, isn't it? I forgot that okay, so to optimize my search system, I know D7 Samurai was working on a string search thing. Maybe he'll throw me a tip here. It's a bit nasty because I had to make it general to the gap buffer, which can have anyway, so let's make spare at least big enough to hold another array of that size, and then that should be able to find the string, and it returns that as let's call that match position, right? So let's say match position equals all that. And so it's just going to search after the cursor for the first thing that matches. So it's obviously not even going to find things before the cursor, which is lame. But for now, it's whatever. I'm just trying to get it to find string matches for now. So it finds that match position, and then from there, I want to take the entire. I need another like thing for grabbing an alphanumeric word, where I know that the word starts at match position, and then I want to keep grabbing everything until it stops matching. So it's like buffer. That word shows up too much for me to search through it that way. Find hard start, seek alphanumeric or camel, left, right, range, camel, right, alphanumeric, left, alphanumeric, right. How does alphanumeric right work? Boom, boom. Okay, so that's the one I want. Seek alphanumeric right. instead of match position, that should be match start, match end. So down here, match start. Match end is just the result of seeking to the right. Alphanumeric right. Buffer match start. Alphanumeric right, match end. Okay. I really need 2 layers of temp here. Here's the first layer of temp. Here's the second layer of temp. Okay. Find string needs explicit end position. Yes, yes, we'll get to that someday. Match start, match end. Yes. Okay, so now spare needs to equal push an array from part char match end minus match start. That gives me the size. And then I can stringify into that. So buffer stringify buffer match start match end spare, right? And then finally, right here, I can insert the spare text, and so I've done that like 3 times, so how about I just stop and make a variable for it. Match size. I've only done it twice. Oh well, still one more time too many, so fine. Yeah, and then that's still going to have the problem that it inserts at the wrong location. I actually want it to replace over word start to word end. Okay. And then I want it to put my cursor at word end when it's done. Okay. Oh no. Please don't build right there. Ah, no. Stop. There we go. So what do we got here? Ooh, oh. Ah, that is a bug. Decrease scroll speed on short windows. Okay. There we go. Yes, you're worried about the temps. .495 begin temp memory being. That shouldn't be being temp memory. That's not a thing. Missing semicolon. Okay. Now I come over here and I run this guy. I open up basic and we try again. Part Control J. Partition. Really? Oh, that's not including semi or underscores. Hey, it's pretty good. I mean, obviously I didn't quite nail it. Oh, So that one does count semi or underscores. I need one. I need a new RC or seek right that does count underscores, and we'll have that sort of nailed. That next little step that I wanted to do today. So let's fix that. Buffer abstract. Seek alphanumeric right. Yeah, I'll copy this. Alphanumeric seek. I'll just call it seek word right. And assume on word. So I'm not going to do any work that says while alphanumeric is true. Yeah, I'm not going to do any work here that says to loop when there we go. But while we're not alphanumeric true, and data position does not equal underscore, right? So really I'm just talking about while it's not alphanumeric. I wonder where that is. Is that under shared? Is alphanumeric or C equals the underscore. Okay. Test basic. Partition. That should have worked. Oh, I know I didn't. Okay. That's because right here, buffer find string, buffer stringify, seek alphanumeric right, seek word right. And there was another part of this name that I did to make sure I didn't use it for dumb things. Buffer abstract. Seek word right, assume on word. That's a nice, healthy, long name. What I should do is just make it less of a pain in the ass to write these loops manually. Then I wouldn't feel the need to wrap all of them in functions. Partition cursor. Alright. Awesome. Size. It doesn't. Okay, what about max? Boom. Size. Awesome. Int. Ernal. Void. Cool. So I would like a files iterator step. Alright. Okay, that's pretty cool. What if I wanted drawing? Boom. Got it. Okay. Yeah. Alright, so that's kind of getting there. Thank you everybody for joining me for today's 4coder stuff stream. It's been fun as always, and I gotta find OBS so that I can shut this thing down now. Yeah, see ya.